Hello students, hope you are all doing well. Welcome to another video by QuickStudy. Today we will start another topic of IGCSE Physics, and our topic for today will be half-life and radiation. So, what is half-life? The half-life of a radioactive isotope is the time it takes for the radioactive nuclei to decay. This process occurs because the nuclei of radioactive isotope are unstable. The exponential decay process is the decay of radioactive substances following an exponential pattern. As time progresses, the pattern of undecayed nuclei decreases at a predictable rate. For each substance, the half-life of half remaining radioactive nuclei decays slowly. This means that the rate of decay slows down over time but never actually stops. It will always keep decaying. And radiation, however, refers to the emission of energy as particles or electromagnetic waves from unstable atomic nuclei. There are mainly three types of radiation, which are the alpha radiation, beta radiation, and the gamma radiation. Alpha radiation consists of helium nuclei, two protons and two neutrons. It has a +2 charge and it is the most least penetrating form of radiation. But it can be harmful if someone digests it, basically eats it or gets it inside of their skin. For example, americium 241 used in smoke detectors emits alpha particles. Beta radiation is composed of high energy electrons, or positrons in other words. It has a moderate penetration power and is stopped by materials like plastic or wood. So it would not go through plastic or anything made of wood. For example, strontium 90 undergoes the decay releasing electrons. Gamma radiation is one of the most powerful ones. It is a high energy electrowave. So it is highly penetrating and requires thick lead or concrete to block. Lead is basically the weakness of gamma radiation. For example, cobalt 60 is used in cancer treatments and emits gamma rays. If, however, all of this is going over your head, then we should start from the basics of an atom. So let's look at this picture where atom is basically divided into three parts, which are the electrons, protons, and its neutrons. So atoms are made up of electrons, protons, and neutrons. This figure shows a simple model of how these particles are arranged. The electron is a very small particle with very little mass. It has a negative electric charge. Electrons orbit around the nucleus of the atom. The nucleus is very small compared to the size of the atom itself. The diameter of nucleus is about 10,000 times smaller than the diameter of the atom. If the nucleus of the atom were to enlarge to the size of a full stop on this page, the atom would be about 2.5 meters. The nucleus is made up of protons and neutrons. Protons and neutrons have almost exactly the same mass. Protons and neutrons are nearly 2,000 times heavier than electrons. Protons carry positive electric charge, but neutrons, as the name suggests, are electrically neutral or uncharged. The amount of charge on a proton is equal to that of an electron but in opposite sign. Basically, electrons are negative and protons are positive, and neutrons, like the name, are neutral. So you might have seen this figure if you have learned the basics of chemistry. This figure basically tells you how you calculate the mass number of an atom. The top left is the mass number and the bottom left is the atomic number. Mass number is basically the number of neutrons added with the number of protons. And in the bottom left, you have the atomic number. Atomic number is basically the proton number you have. So we are learning this because the next thing we will learn is about isotopes. So isotopes are same materials with different mass number but the same atomic number. Similarly, it can be said that materials with the same proton number but different neutron number. For example, here you can see that carbon 12 and carbon 14 are both isotopes of carbon. But carbon 12 has 6 protons and 6 neutrons, while carbon 14 has 6 protons and 8 neutrons. So isotopes are basically of two kinds. One is the stable one, another is the unstable one. Stable isotopes do not undergo radioactive decay, as we have studied earlier, and they remain unchanged over time. But what we will be working on are the unstable or radioactive isotopes. These decay over time, emitting radiation as they convert into more stable forms. So isotopes are basically used in different types of forms. For example, carbon 14 14 is used in carbon dating to determine the age of ancient artifacts. So now that we know about isotopes, now we should have a better understanding what half-life basically is. So half-life of a radioactive isotope is the time that it takes for half of the radioactive nuclei to sample a decay. This process occurs between the nuclei of radioactive isotopes when they are unstable. So they do not work with stable isotopes. We must remember that. So the exponential decay process, as we talked earlier, the decay of radioactive substances follows a kind of pattern which is basically exponential. As time progresses, the number of undecayed nuclei decreases at a predictable rate. We can easily predict the rate when we can calculate the half-life. So there are formulas of half-life. We will learn that in next classes or as we go into deeper into half-life and the radiation chapters. But when we can actually calculate the half-life for each successive half-life, the remaining of the radioactive nuclei basically decay. This means that the rate will slow down, but it will not stop, as we have said previously. So one of the key elements we are learning through radiation are fission and fusion. So you might have heard about fusion before, but fission might be a new thing to you. So what we have learned so far, the half-life and also the radiation and about isotopes, basically come to this part. So fission is the process where a large unstable nucleus, for example like uranium-235 or plutonium-239, splits into two smaller nuclei, releasing a large amount of energy and additional neutrons, which can induce further fission reactions. For example, they can mainly divide into further elements. So, for example, in a nuclear reactor, a neutron collides with a uranium-235 nucleus, splitting it into krypton 92, barium 141, and releasing 3 neutrons and energy. So on the other hand, fusion is the complete opposite. In fusion, two light nuclei basically come together to form a bigger nuclei or nucleus. So releasing energy in the process. So even when they get together, they basically release energy. This is the process that powers the stars, including the sun. So sun basically runs through fusion. All the light nuclei come together and form a bigger, better hydrogen process. So that is how basically sun works. For example, in the sun, 4 protons for hydrogen nucleus combine into series of steps to form helium, releasing vast amount of energy, and that is how we get the heat and light from the sun. So in this video, we have learned about half-life, radiation, and about isotopes. We also have learned about fission and fusion reactions. So we have learned how to calculate the mass number and also how the atoms are formed, about protons, neutrons, and electrons. So this will basically help you to understand the basics of radiation and half-life. That's all for today, students. Stay with us to learn more about IGCSE Physics and other subjects as we post regularly on our channel. To learn more about our online tutoring services, do visit www.quickstudy.uk.